right. Good evening, everyone. How you guys doing? Didn't sound right. How you guys really doing? That's better. Right. So I'm Nishan Thakur. I'm a technical product manager, making sure that the analytics and AI set of services are ready for customers like yourself to leverage and do more with. In this particular session, I'm just going to give you a very kind of smooth transitional introduction to Azure Databricks and the big data processing workloads surrounding it, right? And I'm going to take the example of a particular industry so that we can relate to it. Now, it's not that that is the only industry that we deal with. There are a lot of verticals where big data processing is important, so I just want to make that clear up front as well, right? Now, before we even get started, I actually wanted to draw up something that Forrester's been trying to communicate via a lot of their reports and all of the analyst analysis, etc. as well. Now, the idea is that more than any other factor, it's the customer experience that's defining whether companies thrive and profit or they struggle and fade away. Now, it's an important facet. Customer experience essentially means that you need to have an understanding of your customers with a 360-degree view of them. And for you to be able to do that, you need to have a very sophisticated environment and a system to achieve it. Now, what does that translate to? Well, that actually translates to customers like yourselves having a lot of high expectations of the analytics and AI ecosystem as a whole. Essentially, you need it to be very fast. Speed is a very, very important facet. Second, you want it to be consistent as well as available on-prem, cloud, and hybrid. And the third, it needs to be personalizable or customizable as we think about it, all right? Now, how do we leverage all the data that we possess to achieve that and to maintain those high expectations is the name of the game within the analytics and AI businesses. Hope it's still showing that. So, to enhance any application with big data analytics, there are a certain set of steps that you actually go ahead and take. But just for us to be able to understand what are these apps that we are talking about, these are not restricted to any particular domain, etc. These could be e-commerce apps, could be gaming apps, could be social apps, could be business apps, or they could even be IoT apps for all we care, okay? Now, what do you need to actually do with them? To explain that, I'm going to take the example of Worldwide Importers. Now, Worldwide Importers is a fictitious company. It's like Contoso, all right? Now, like Contoso, what we've done is we've created a bunch of scenarios around Worldwide Importers and how they leverage their data to harness the power of analytics and AI. So what are they trying to do? Well, currently, they are just a brick-and-mortar retail store. And what are they trying to get to? Well, they're trying to get to an omni-channel retail environment. They want their brick-and-mortar stores to resist. They have the web e-commerce, the whole paradigm to capture over there. And then the growing mobile and e-commerce space as well, for them to be able to see the benefit of their data and to leverage more of it to grow their businesses. Now, what does that solution need to have? It's easy to say that they need to harness the data. What does that actually mean? One is, they need to be able to scale and reach more consumers so that they can grow their business to the levels that they expect. Second is, they need to unlock insights from unstructured data and semi-structured data, which all this while they've not been able to do because 70% of their data comes in files and semi-structured formats, and then they throw it away because their systems cannot manage that or cannot handle that and cannot ingest that data to give them any kinds of insights. The third is, how do they leverage all of this data to create insights around their users that can serve them better? The fourth is, all of this is fine. Can I do this in real time so that when my user comes now, I'm able to give them that insight right away rather than making them wait for weeks, if not months, and then getting that insight and giving that experience by the time which the customers moved on to another portal or another vendor or another partner? And then the other thing is, how do you improve the experience by infusing AI into everything that they do? To do that, we're going to leverage Azure Databricks here. Now, I want to spend a couple of minutes on this slide over here because I want to explain how everything that we understood from a requirements perspective on the previous slide applies to the product capabilities that we are talking about. We talked about scale. What if we gave you a distributed processing environment that you could grow to the scale that you desired? You could keep it as small as a 2-node cluster. You could grow it as big as a 20,000 node cluster and have your data being processed over there. Second, we talked about generating insights from it, which translates to you being able to properly process your structured, semi-structured, as well as unstructured data all in the same environment using the language and tools that you're familiar with. What if I gave you an environment where you had a simple notebook-like experience and you could use Python, Scala, SQL, R, and Java to process any kind of data the way you wanted to? Third, we talked about bringing these insights to customers. Well, what if I told you that same environment could connect first to your underlying data sources, like your data lake, which stores any kind of data, but also to the frontline operational databases like SQL DB and Cosmos DB and SQL Server and Cassandra and MongoDB and any other operational data environment that you have, to be able to push these insights into so that your applications now have a better understanding of what this process data looks like and is able to offer it to your customers. Fourth, what if I told you that the same environment would allow you to do batch processing, stream processing, as well as machine learning, and you could take advantage of the same tools and the same languages to do everything in there? And fifth, what if I could extend this environment to do deep learning processing with TensorFlow, MXNet, PyTorch, Caffe, Keras, or any other framework that you want to bring on top of this? And to add to those requirements, what if I added on to say that this is with the freedom of the open source analytics platform that Spark is? Now that's what Azure Databricks comes to offer all of you over here. It has connectors built in to the rest of Azure. So it's a single environment inside of Azure. You can connect to storage services. It's safe and secure with native integration to Azure Active Directory. It integrates with all the underlying data sources like SQL DW, Cosmos DB, as well as SQL DB. It can ingest and batch in real time, be it Kafka or Event Hubs, or be it any other environment. And it offers you a single bill and allows you to connect from your choice of BI tools like Power BI. That is Azure Databricks for all of you over here. Now, I actually want to go ahead and dive into the demo right away to show you some of that experience as well. Hoping. So here I have an Azure Databricks workspace. Of course, you go into portal.azure.com, you look for Databricks, you spin up a workspace, it takes a few minutes, a couple of minutes actually, and then you launch that workspace. And this is the page that you get to, all right? Now, workspace is a unique concept altogether as well. It stores all of your notebooks, that's your development environment, and metadata around all of the data connectors that you're connecting to, alongside any custom libraries, etc., that you're bringing into this environment. All right? Now, this workspace has the ability to allow you to spin up your own clusters, and I have a couple running right now, but I could go ahead and create new ones. And all that it takes is, it asks you for a cluster name, it asks you for a particular version of runtime, depending on what you want to run on it, and what version of the tools and languages you want to use. And then it asks you for the size of the cluster. It basically asks you how many nodes do you need, how big your environment is, how big your data is. And depending on that, you can ask it to size it accordingly. Now, one of you might ask me, well, I don't really know how my data size translates to processing size. What do I do here? Well, we've thought about that too. We've made sure we enable auto-scaling by default on all clusters. So now, you don't have to definitively define the size of your cluster. If you can give us a range, and that range could be from 2 nodes to 2,000 nodes, and all we care about is what's the load on your cluster, and we will scale this environment up and down according to what your data sizes and your job sizes look like. Now, that's not all. These cluster environments tend to get very expensive very fast, because imagine having 1,000 nodes running in parallel. You're paying for that much compute power. You don't want that environment to sit idle even for a couple of hours. So what we've added is the capability for you to auto-terminate this environment within a certain span of time. You can specify this to be 10 minutes so that it looks for your environment. It says, you know what, nobody's using it, nobody's firing up any queries on it, nobody's bringing any more data into it. Well, it seems like I'm sitting idle. I might as well shut down till they need me again. And that's the ability for you to do that in an automated fashion. Now, the other important thing that I want to dive into is this notebook experience. Now, notebooks are a very novel concept. These are very close to data engineers and data scientists that really do some customized data engineering pipelines for themselves. These are environments which allow you to write code, execute them, visualize result, all at one place. You can come in here, type your code, and start visualizing and executing your code inside this environment. Mind you, this notebook is actually hosted on a web portal. So you don't need to install any tools on your desktop. You could be anywhere. As long as you have access to the workspace, you can just log in and go ahead and authorize yourself against your Active Directory token, because it's secure, mind you, and you have access to this environment to start coding all by yourselves. Now, this is not all. It integrates with GitHub for all your version history. It is collaborative, so you can share this environment with other colleagues in your organization, and you all can build together on top of this. You can even go ahead and schedule it to run at a particular interval or a particular schedule as you would like it. What's even better is that you can specify what language you want to use, and you can use that particular language. You can use Python, or Scala, or SQL, or R, or Java, whatever you want to bring in. And it even allows you to fire up shell scripts from inside the notebook and experience itself. Now, in this case, what I'm trying to do is I'm trying to improve for wide world importers. I'm trying to improve the product discoverability. All right? They've got a set of products. They're not doing so well. Now, what do I do about it? For me to be able to do any kind of analysis, first I need data. So what is the data that I'm dealing with over here? The first set of data that I'm dealing with is, of course, we made a lot of sales. Where is all of that sales data? There is product sales, right? It's sitting in the data warehouse. Can I pull it from there? Of course. I can very easily go ahead with a native connector from within Azure Databricks to the SQL data warehouse. I can subscribe to that data, and I can pull that data to visualize it and analyze it very easily. Now, but then this is all structured data. This is in the form of a table. This is all a rectangle. It's rows and columns. There is a lot of data on what my users do on my websites. Where is that data? Can I get an understanding of whether people are clicking on certain products and not buying them? Or they're spending too much time just looking through some of those products and not being able to get to the exact product that they want? Well, all of that data is stored in semi-structured or unstructured format in my blob storage. So now I can go ahead and connect using a very simple connector into my blob storage or data lake and pull in my unstructured data. Well, I can't make any sense of this data. How do I query this? I cannot. How do I join this with my product sales? I cannot. Well, why not? Within Spark, I can now go ahead and define this as a data frame and convert it into a tabular structure as well. Now, this allows me to take this data frame or this table and the other data frame and join them to derive combined insights. This is just one example of bringing together structured and unstructured data together and deriving combined insights over here. A visualization of such an insight would be something like this. This is exactly what I've done over here. Just join them with both of those data frames, and I am applying certain filters and certain aggregations to these. Now, what does this graph tell me over here? Well, this graph tells me when my products are released, there is very low demand for it. They pick up for a little while, but then they dwindle down. And then again, they pick up towards the fag end of their life cycle. What does that tell me? That tells me that when I put it on discount or clearance, that's when my product's actually selling. It's not selling otherwise at all. Which tells me there is an underlying problem in product discoverability itself. People are not being able to find the product early on in the life cycle. If I could make sure that the products were found early on, maybe they would sell early on. So let's see how that's happening. Well, I'm going to employ data science here to improve my product visibility. Here, I have a pretty sophisticated LSH model in place. All I need to do over here with that LSH model is to make sure that I put it into the data shape and get results from it. Now, this is a machine learning model, a sophisticated one, so it should give me good results. And this is what I'm using for my recommendations. So why there is low product discoverability? Well, as I see, when I run my model and I give it a source image, let's say this is the product that I was looking at, the recommendations that I get are very different. For a women's sandal, I'm getting recommendation for men's sandals and open toes. That's not ideal. That literally means that the shoes business is definitely not going to do well. My products are not going to be discoverable at all. But how did we make that out? We made that out from these images over here, right? We observe those images. So why can't I train my machine learning model to observe those images? Now we are getting into the realm of AI and deep learning. Well, all within the same environment, I'm going to trigger off an image featurizer to go ahead and take those images and featurize them. And when I execute it, it's going to extract features from those images, like its color, like its pattern, like its other features and attributes, and add those to the machine learning model to give me even better insights. Here, I'm using a pretty sophisticated TensorFlow model in the backend. And now when I run the same model, I see much better recommendations coming off it, which essentially means my product discoverability was very bad earlier. When one of you was going to worldwide importers' sites, you were not seeing the products you wanted to buy. And now, within the recommendations, you will be able to see it. Now, one of you might challenge me that, you know what, you just trained it for these images. Probably it just shows for those images, and probably every image I pass to it is going to show the same set of recommendations. That's actually called overfitting a model in machine learning parlance. To make sure that we don't do that, we test it out with other images as well, that it really gets an understanding of the data sets and does it. Now understand this. We dealt with structured data coming from a table. We dealt with unstructured data coming from files that we could not decipher with our naked eyes. We dealt with images that were collected potentially off the web, and we've trained a model to be very sophisticated. Now, how do I deliver this insight to my customers? Well, I need all of these recommendations in order of their probabilities to be stored in an operational database. I'm going to take the example of my favorite operational database, that's Cosmos DB. I'm running a single cell over here using a native connector from Azure Databricks to Cosmos DB, and I'm exporting all of these recommendations into Cosmos DB for it to serve on the web and mobile platforms. Now my apps are more intelligent because I've leveraged machine learning to understand my customer behavior, and I've leveraged deep learning to optimize that understanding and generate recommendations and predictions for me. And now my database is more intelligent because it contains the output of all of this processing that has happened on top of massive big data clusters inside of Azure Databricks. Now, this is a perfect example of what you would see when you actually get into the realm of big data processing with Azure Databricks. I actually just want to go ahead and take a few minutes to run through some of these logical architectures that we evolved during the course of this discussion and this demo. The first one is the modern data warehouse. Well, you have a data warehouse, you can do a lot with it, but then you cannot do anything with unstructured and semi-structured data with it. That's where the construct or the concept of a modern data warehouse comes in. You are literally expanding or extending your data warehouse with capabilities in Azure Databricks to process your unstructured and semi-structured data. Your data lake still remains the same, and you can rely on it to bring in all of your data and secure all of your data as well. Now that's just the first frontier. The second frontier is advanced analytics or machine learning. You can leverage the same element, a different cluster or the same clusters of it as well, to now go ahead and do machine learning in the choice of language that you want, or the choice of library or framework that you want to employ, whether it's Spark R, Spark Machine Learning, H2O, or whether it's Sparkly R, or from a TensorFlow standpoint, whether it is TensorFlow, PyTorch, or going ahead and exporting it into Onyx models, and then being able to deploy it very easily to underlying operational stores to serve to your intelligent apps. But that's not all. You can do that for batch, that means compile data, as well as real time, that means streaming data. You can bring in data in real time using Azure Event Hub or Kafka in Azure HD Insight and feed it directly to your Databricks environment to score against machine learning models and then infuse in your BI tools or apps. Now that's the simplicity of having an environment as powerful and as natively integrated as Azure Databricks for all of your big data processing needs. I hope I was able to give you a good glimpse of this environment, and I hope you give it a try. We actually have a good 14-day free trial running on Azure Databricks as well, so you don't have to pay for Databricks separately, and you can try it out for your scenarios. Thank you so much for sticking by, and I'm here for any questions that you may have. Thank you.